Every time you flip on a light switch, send a text message, or even just take a breath, you are depending on one single invisible architect. Today, we're going to dive into what might just be the most important particle in the entire universe, the electron. So let's just ask the big question right up front. What is that one particle? Well, you already know the answer is the electron. And trust me, by the time we're done here, you're going to see how this one tiny, tiny thing is responsible for, well, pretty much everything. So here's the plan. We're going to start super small with the particle itself. Then we'll zoom out to see how it builds atoms, how those atoms create molecules, and how all of that ultimately powers our entire world. And you'll want to stick around because at the very end, we're going to do a quick experiment that makes this invisible force visible. Okay, first things first, the particle. Before we can get into how it builds our world, we've got to get on the same page about what an electron actually is. To put it simply, an electron is what we call a fundamental particle. That just means it's not made of anything smaller. It's one of the true basic building blocks of the universe. I mean, without electrons, atoms can't form. And if atoms can't form, well, nothing we know could exist. They are absolutely essential. And, it's not like we've known about them forever. We only figured this out back in 1897. A physicist named J.J. Thomson discovered them. And that discovery really kicked off our entire modern understanding of what stuff is made of. Now, if you remember one thing, remember this. Electrons have a negative charge. This one simple fact is the key to everything else we're going to talk about. It's what drives chemistry, it's what creates electricity, it's the secret that holds our world together. And hey, don't let their tiny size fool you for a second. These things are unbelievably energetic. They move at insane speeds, and as this quote says, they really pack a punch. An electron has a ridiculous amount of energy for how small it is. It really is the bodybuilder of the subatomic world. All right, so we've got this tiny, super energetic particle. What happens when it joins a team? When it becomes part of something bigger, like an atom. Well, this is where things get really interesting, because electrons are what give each atom its unique identity. So here's the really cool part. In a normal, balanced atom, the number of electrons orbiting the center is what defines what element it is. It's not the size, it's not the weight, it's the electron count. That number is like a unique fingerprint for every single element. Just take a look here. An atom that has 8 electrons is always oxygen, the stuff you're breathing right now. But an atom with 29 electrons, that's always copper, the metal that's probably in the walls of your house. A different number of electrons, and you get a completely different substance. Okay, so electrons give atoms their identity. That's cool, but individual atoms are kind of lonely, right? How do they get together to create all the amazing stuff in our world, from water to wood to plastic? Well, the answer, once again, comes down to electrons. This is the next logical step, isn't it? If you have a bunch of separate hydrogen and oxygen atoms just floating around, what is the glue that sticks them together? What makes them decide to team up and become a brand new molecule, like water? Well, here's how it happens. Atoms don't just randomly bump into each other and stick. They form powerful connections by sharing their outermost electrons. So when one oxygen atom gets close to 2 hydrogen atoms, they agree to share some electrons. And boom, they're all locked together, and you've got H2O, you've got water. I love this analogy because it's so perfect. This sharing process is called a chemical bond. And it really is just like atoms holding hands. That connection, that shared electron, is what physically holds molecules together. And that right there, that's the secret sauce of all chemistry. Through this simple act of sharing electrons, individual atoms can combine to make something completely new, with totally different properties. That's how we get literally everything. All right, we've gone from the particle to the atom to the molecule. Now let's take our final step back and look at the really big picture. We've seen how electrons build matter, but what happens when they stop holding hands and start moving on a massive scale? Well, in certain materials, especially metals like these, the atoms aren't super clingy with their outermost electrons. They kind of let them float around freely, creating this sea of electrons that can easily jump from one atom to the next. Now, this is a super important distinction, so let's get it straight. The actual movement, the flow of all those free electrons hopping from atom to atom, that's what we call an electric current. And the energy that this moving flow carries with it, that's what we call electricity. It's the power we actually use. So think about that. When you flip a light switch, you're not doing anything magical. You're just completing a path, giving the green light for trillions and trillions of electrons to start flowing through a wire. It's this microscopic stampede that, quite literally, runs our entire civilization. I know, this all sounds a little invisible, doesn't it? A bit abstract? So let's make it real. You can actually witness the incredible force of electrons for yourself, right now, with a super simple experiment. Seriously, go ahead and try this. If you have a balloon, inflate it. Now, rub it really fast on your hair. Get some good friction going. What you're actually doing is scraping electrons from your hair and piling them up on the balloon's surface. Now, slowly pull the balloon away from your head. See that? Your hair stands up and follows it. That's the pull, the attraction you're seeing. You are literally watching the force of electrons at work. So, from the very identity of an atom all the way up to the power grid of an entire city, it all comes back to this one little particle, the electron. It really makes you wonder, doesn't it? If this one tiny invisible force has such a profound impact on everything, what other unseen forces are out there, quietly shaping our reality every single day?